Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is sum of distances in a tree. So we are given a undirected connected tree, which will consist of n nodes, which will be labeled from 0 to n minus 1. And then we are given n minus edges, which is present in this tree. And then we need to find the answer of length n, where answer of I equal to sum of the distances between ith node in the tree and all other nodes. Suppose let us take this particular example where we have this. Now we need to calculate the answer, which will consist of an array of size length n, and then it should be the array of I is going to give us the answer of the distance between this node with all other nodes. That means suppose let's say I want to take 0, then I am going to calculate the distance between this node with 1 and then 2 and then 3 and then 4 and then 5. So if I calculate the distance, it is going to be 1, and then for this it is going to be 1, and then for this 2, and then for this 2, and then for this 2. So if we add this, it is going to be like 6, and then 7, and then 8. So we are going to return 8 for array of 0, and then for other elements it is going to be same. So we need to find all the distances for this particular n nodes. And then if we see the n range, it is going to be from 1 to 3 into 10 to the power of 4. That means if we solve with, suppose let's say if we take with each each node as our source node, and then if we try to calculate, then it is going to be the number of nodes, and then we need to calculate n plus c times if we use bfs or dfs with taking one node as source, and then it is going to be like big of n square, which will be time limit exceeded. So we need to solve it in a better way. So let us take and then try to figure out like how we can solve this solution. Suppose let us think that we have a node and then we need to calculate the distance. Suppose let's say this is the node, and then I want to calculate the distance between this node and then all other below nodes which are present. So for this node, let us take this node which is 2, and then for this let us calculate the distance between 2 and then 3. It is going to be 1, and then for this it is going to be 1, and then for this it is going to be 1. So the distance between this node with all these below children node is going to be 3. And then now when we see this particular node from these nodes, it is going to be the distance of 1, and then it is going to be the distance of 2, and then it is going to be the distance of 2, and then it is going to be the distance of 2. But when we calculate the count is going to be the number of children which are present. For this, the number of children and then this node is going to be 1. Why? Because we contain only one node which is present here. And then for this, count is going to be 1. And then the count is going to be 1 for this. And then let us calculate the distance between this node with all other children. For this, it is going to be 0. And then for this, it is going to be 0. And then for this, it is going to be 0. We are trying to calculate the distance between this node with all other below nodes, and then count will store the number of nodes which are present. Now when I take this node which is here, now I am calculating the distance between this node with all other its children. So for all other children, I need to take the distance between this and then the number of counts. Suppose if I take this, I'm going to increment all the counts, and then I'm going to get the count as count of children plus 1, which is going to be already equal to 1. So now for this, I'm going to add the count, which is going to be 3. And then for this, the distance is also going to be 3. And then for this, when we come back here, the distance is going to be 3 as we are adding this. And then one more thing is we are going to add the count is going to be count plus 3, which is 3, and then this 0 is also present, that's why it is going to be 4. And then whenever we are adding the distance for this particular node is 3. The distance between all other nodes with this particular node is 3. But when we are shifting this particular distance to here, that means we are calculating all these nodes to with relative to this. Suppose let us take one example where we have 2 points, some x1 minus some x1, and then we are going to calculate x1 with relative to x, and then x2 with relative to x. Now when we are doing this, let us shift this x with one more distance, which is going to be plus 1, and then it becomes like, let us increase this distance, which is going to be like plus 1, and then minus x plus 1. Now for this, the distance is going to be increased with 2. Why? Because it will be added like x1 plus x2 minus 2x, which will be same, and then we are going to do minus 2. So this is going to be our distance, but this distance has increased with the length of 2. Why? Because suppose let's say this is with the value of, this is with the value of 3, and then this is with the value of 1, and then this is with the value of 0. Now initially the x is 1, so we'll get as x as 1, and then we had decreased it to minus 1. So that means it becomes like minus 1, and then here also it is going to be minus 1. So it is going to be minus 1, and then it is going to be x1 plus x2 minus 2x, and then it is going to be plus 2. So now the distance has increased to 2. That means when how many ever the points are present, we are going to increase those many times. That means we are going to take the distance, as well as we are going to consider all the answer which is present. That means we are going to consider 3 plus count which is present with the node, which is going to be 3, and then this gives us the answer of 6. And then we are going to calculate, for this it is going to be 1, and then the distance is going to be 1 for this again, and then again we are going to increase this answer with 6 plus distance is going to be 1, and then count is going to be 1, which is equal to 8, and then the count will be increased to 5 here. Why? Because we are adding one more element which is present. So this is 4, and then this is 5, and then this is going to be 6. So it is going to be 6. So this one is going to become 6. And then now we need to calculate the distance between all other nodes. Suppose let's say if I consider this node, we considered only the distance between this node and then this node, but we did not consider the nodes from this upper part. That means I'm not considering this distance and then this distance with this particular node. Now we are going to do the same thing. We are going to consider the DFS from here, and then I'm going to get the answer by using this particular answer. Now I got 8 as my answer for this, and then now I am going to use this 8, and then I'm going to calculate this answer. Suppose let's say I got this distance. Now I need to calculate this distance. So to calculate this distance, I'm going to consider, suppose let's say the number of nodes which are present is n. So these nodes distances will be increased by 1. Why? Because I'm shifting this node from here to here. That means I'm going to increase the distance of child is going to become distance of root parent. This is going to be my parent. On this, I'm going to increase the number of nodes from this nodes, like the number of nodes in the left hand. Like I'm going to consider these nodes which are going to increase the distance. For this, it is going to increase the distance. So that is going to be n1. And then let's say these are the number of nodes. That means I'm going to shift from here to here. That means these nodes distances will decrease via n2. The number of nodes which are present is going to decrease with n2, and then this is going to be my answer. And then for this, if we consider n1 and then n2, n1 and n2 we are going to calculate with Suppose let's say the number of total nodes is already n. We know that. That is going to be distance of parent plus the total number of nodes which are present is n. Out of this, we are going to take out this particular count, which is going to be count of child, count of child, and then I'm going to take out the n2 is going to be count of child. That means I'm going to do again minus child minus count of child. So this is going to be 2 count of child. So we are going to add that 2 into count of child. So this is going to be our distance of child is going to be distance of parent plus n1 minus n2, and then we are going to consider distance of parent plus n minus 2 count of child. So that is going to calculate the distance of all other nodes which are present with this child node. So that is how we are going to consider. So let us go through the solution for this. So the time complexity is going to be big of n, and then E is going to be the number of edges. So what we are going to do is we are going to construct the tree with the with the edges which are provided with tree of E of 0 with pushback of 1, and then we are going to take the edges. Suppose let's say we have a edge between U and V. Now U is connected with V, U is connected with V, and then V is also connected with U. Now when I call with U, it should give all the results of V and then other edges, and then when I call with V, it should give the edges of U and all other edges. That's why we are going to add into our adjacency list so that we can get all adjacent elements which are present. And then we are going to do the DFS traversal. This DFS traversal will calculate the distance between the children and then the root. So we are going to take the parent, which is going to be previous, and then this is going to be our root. So for this root, we are going to consider, suppose if I equal to parent, then we will not consider this. If it is not, then it is going to be child. So for this, we are going to do the DFS again, and then we are going to increase the number of nodes which are present with the count of these children. This is going to be like 1 plus this, and then 1 plus this, and then 1 plus this. For this, the count is going to be 4. So that's how we are going to increase the count, and then we are going to increase the distance as distance of I and then count of I. Suppose when I want to take here, the distance will be distance plus the count of this. Why? Because we are increasing the distance for these many counts with this. That's why we are adding count. And then after we are done with the first DFS, we are going to do the reverse, which is going to be like calculating the distance of child from the parent. From parent, we are going to calculate the distance. For these many number of nodes, we are going to increase the distance. That's why we are going to add n1. And then for these number of nodes, we are going to decrease the distance. That's why we are going to add minus 2, minus n2, and then we are going to convert n1 is equal to n minus 2 of count of child, and then n2 is going to be count of child. So that's how we are going to see. So the position is equal to I, then we will not consider. And then if the result of I equal to result of root plus rest dot size, which is going to be n, and then 2 into count of I, and then we are going to do the DFS traversal again, and then at last we are going to return the answer. So for this, the time complexity is going to be big of n into E, and then the space complexity is going to be big of n. Yeah, that's all for this video. Thanks for watching the video.